Hi there, this is Architect David. Welcome to Arkida, where you can learn anything and everything about construction. For this episode, we will be discussing about the science of acoustics or the sciences involved in acoustics. Electroacoustics or acoustical engineering. This branch of acoustical engineering deals with the design of the headphones, microphones, loudspeakers, sound systems, sound reproduction, and recording. There has been a rapid increase in the use of portable electronic devices which can reproduce sound and rely on electroacoustic engineering like mobile phones, portable media players, and tablet computers. A loudspeaker, or speaker driver, or most frequently known as speaker, is an electroacoustic transducer, that is, a device that converts an electrical audio signal with a corresponding sound. A speaker system, also often simply referred to as a speaker or loudspeaker, comprises one or more such speaker drivers, an enclosure, and electrical connections, possibly including a crossover network. The speaker driver can be viewed as a linear motor attached to a diaphragm, which couples that motor's movement to motion of air, that is, sound. An audio signal, typically from a microphone, recording, or radio broadcast, is amplified electronically to a power level capable of driving that motor in order to reproduce the sound corresponding to the original unamplified electronic signal. This is thus the opposite function to the microphone, and indeed the dynamic speaker driver, by far is the most common type. It is a linear motor in the same basic configuration as the dynamic microphone, which uses such a motor in reverse as a generator. The dynamic speaker was invented in 1925 by Edward W. Kellogg and Chester W. Rice, issued as U.S. Patent 1707570, April 2 of 1929. When the electrical current from an audio signal passes through its voice coil, a coil of wire capable of moving axially in a cylindrical gap containing a concentrated magnetic field produced by a permanent magnet. The coil is forced to move rapidly back and forth due to Faraday's law of induction. This attaches to a diaphragm or speaker cone, as it is usually conically shaped for sturdiness, in contact with air, thus creating sound waves. In addition to dynamic speakers, several other technologies are possible for creating sound from an electrical signal, a few of which are in commercial use. In order for a speaker to efficiently produce sound, especially at lower frequencies, the speaker driver must be baffled so that the sound emanating from its rear does not cancel out the intended sound from the front. This generally takes the form of a speaker enclosure or speaker cabinet, an often rectangular box made of wood but sometimes made of metal or plastic. This enclosure's design plays an important acoustical role, thus determining the resulting sound quality. Most high-fidelity speaker systems include two or more sorts of speaker drivers, each specialized in one part of the audible frequency range. The smaller drivers, capable of reproducing the highest audio frequencies, are called tweeters. Those for middle frequencies are called mid-range drivers, and those for low frequencies are called woofers. Sometimes the reproduction of the very lowest frequencies, which is 20 Hz to 50 Hz, is augmented by a so-called subwoofer, often in its own large enclosure. In a two-way or three-way speaker system, one with drivers covering one or three different frequency ranges, there is a small amount of passive electronics called a crossover network, which helps direct components of the electronic signal to the speaker drivers best capable of reproducing those frequencies. In a so-called powered speaker system, the power amplifier actually feeding the speaker driver is built into the enclosure itself. These have been more and more commonly used, especially as computer speakers. Ultrasonics. It is the vibrations of frequencies greater than the upper limit of the audible range for humans, that is, greater than about 20 kHz. The term sonic is applied to ultrasound waves of very high amplitudes. Ultrasonic devices are used to detect objects and measure distances. Ultrasound imaging or sonography is often used in medicine. In the non-destructive testing of products and structures, ultrasound is used to detect invisible flaws. Again, ultrasound is sound waves with frequencies higher than the upper audible limit of human hearing. Ultrasound is not different from normal or audible sound in its physical properties, except that humans cannot hear it. This limit varies from person to person and it's approximately 20 kHz in healthy young adults. Ultrasound devices operate with frequencies from 20 kHz up to several gigahertz. Ultrasound is used in many different fields. Ultrasonic devices are used to detect objects and measure distances. Ultrasound imaging or sonography is often used in medicine. Psychoacoustics is the branch of psychophysics involving the scientific study of sound perception and audiology, or how humans perceive various sounds. More specifically, it is the branch of science studying the psychological responses associated with sound, including the noise, speech, and music. Psychoacoustics is an interdisciplinary field of many areas, including psychology, acoustics, electronic engineering, physics, biology, physiology, and computer science. Psychoacoustics is the psychophysical study of acoustics. Okay, psychophysics is the study of the relationship between sensory perception, psychology, and physical variables, physics. Example, how does perceived loudness or the perception relate to sound pressure level, which is the physical variable? Psychophysics was coined by Gustav Fechner in his book Elemente der Psychophysics, or The Elements of Psychophysics. Fechner's treatise covered at least three topics: psychophysical methods, psychophysical relationships, and panpsychism. Today, psychoacoustics is usually broadly described as auditory perception or just hearing, although the latter term also includes the biological aspects of hearing, which is physiological acoustics. Signal processing refers to the acquisition, storage, display, and generation of signals. Also to the extraction of information from signals and the re-encoding of information. As such, signal processing in some form is an essential element in the practice of all aspects of acoustics. Signal processing algorithms enable acousticians to separate signals from noise, to perform automatic speech recognition, or to compress information for more efficient storage or transmission. Signal processing concepts are the blocks used to build models of speech and hearing. As we enter the 21st century, all signal processing is effectively digital signal processing. Widespread access to high-speed processing, massive memory, and inexpensive software makes signal processing procedures of enormous sophistication and power available to anyone who wants to use them. Click the subscribe button to discover all the other videos in this site. Click the notification bell to be notified about new videos that we post. If you have additional comments, please post them down below or at our Arkida Facebook page, and I will answer all your queries. Thank you.